Hello and welcome back to Psychiatry XR. I'm your host, Jessica Hagen, and I'm joined by my co-host, Faaizah Arshad.
Hi, Jessica. Really happy to be here.
Happy to have you here. We're excited to have Sam Glassenberg join us today as well. Sam Glassenberg is the founder and CEO of Level X, a medical video game studio. Sam has spent his career leading companies at the cutting edge of the video game industry. At Level X, his team harnesses video game technology and cognitive neuroscience to train over 1 million medical professionals. Sam was previously CEO of the top independent game publisher in Hollywood. He also led Microsoft's DirectX graphics team and created games at LucasArts. He serves on industry advisory boards and speaks internationally on video games and medicine. Sam, thank you so much for joining us.
Thank you. Thrilled to be here.
We're so thrilled to have you here. Can you tell us a little bit about Level X and how it works within the intersection of virtual reality and psychiatry?
Sure. Well, look, first I have to say, we say Level X is like the Matrix. You can't be told what Level X is. You have to see it for yourself, which means it's not necessarily ideal for the podcast format, but we'll see what we can do.
Okay, great.
So Level X is a medical video game studio. So what that means is we're using the technology, and more important than the technology, we're using the neuroscience-based design of video games to, say, advance the practice of medicine, to accelerate the adoption curve of new skills, techniques, therapeutics, guidelines, devices. Like you said, we have 1 million medical professionals playing our games where they're earning continuing medical education credit, AMA Category 1, while they do everything from perform surgery on virtual patients in, complex, rare, difficult surgical scenarios to diagnosing rare disease, managing complex patients over time. And we're also working with 20 out of the top 40 life science companies and med device companies to help train doctors and other medical professionals on their products. And we work with major medical societies as well as NASA to use these technologies and these design techniques to disseminate best practices and literally train astronauts how to deal with medical emergencies in space. Most of our content is on mobile, but we do a lot of headset and VR content. So we've had about, like I said, 1 million medical professionals play our games on their phones. We've had about 70,000 play our mobile AR experiences where you use your phone to, let's say, project a virtual patient into your room, to intubate them, perform CPR on them, talk to them, whatnot. And then we've had probably about 7,000 people, medical professionals, play our headset-based games in VR and AR. So like we had some of the first medical content on Oculus, on HTC Vive. We were the first medical content on Magic Leap 2. So we're always leveraging the latest technology where appropriate to help accelerate the adoption curve in medicine. Specifically in psychiatry, like we don't have a dedicated psychiatry game, but we've been doing a lot of work with different companies and groups to accelerate the development of certain skills, especially at the intersection of psychiatry and neurology. So things like using, we call role-playing game dialogue mechanics to have conversations with virtual patients. So for decades, consumers have been playing role-playing games where you have to talk to a virtual character and ask the right questions or say the right things in order to, unlock the clue to play the next quest. We use some of those same mechanics to help train bedside manner. How do you ask the right questions in the right sequence to get the information you want? How do you ask the right questions to really do a more nuanced diagnosis? How do you use it to drive adherence so patients understand why you want to get the vaccine or not? So we're using these technologies for everything from how to have a conversation with a patient, how to program a deep brain stimulation probe, how to understand the mechanism of action of different therapeutics and pharmaceuticals, how to treat the side effects of antipsychotic medications.
Yeah, that's actually one thing that I wanted to mention to you too, is we had a previous discussion where you had mentioned that Level X uses games to train doctors to diagnose and treat patients with neurological conditions caused by psychiatric treatments. And I was wondering if you could just expand on that a little bit, as that sounds quite interesting to me.
Sure. So we were just nominated actually for an award for this. We did a project with Neurocrine Pharmaceuticals to help train doctors to identify tardive dyskinesia, which is a side effect of certain antipsychotic medications, but it presents often very similarly to other lookalike diseases. It's very difficult to discern the TD tremor, for example, from a Parkinsonian tremor.
Oh.
And so what we do is we're literally using video game technology that for the last, 20 years we've been using to make ultra realistic video game characters for everything from Dance Dance Revolution to Call of Duty. And what we do is we utilize some of that same ultra realistic character animation technology to create systems that allow us to generate any movement disorder on any part of the body at any severity on any patient type, overlaid with any other movement. Like, how does this appear when they're walking, when they're talking, when they're, trying to touch their fingers, things like that.
That's fascinating. So you've spent much of your career in video games, as we highlighted. In your experience, how do games, virtual reality games in particular, make an impact on patients in the clinical setting? And how can they help psychiatrists enhance their practice?
Okay, so the first thing to understand, so at Level X specifically, the games we make are focused on medical professionals.
Right.
However, we're utilizing the same neuroscience that is also being used by digital therapeutics. Essentially, video games are exceedingly good at triggering the release of specific neurochemicals at the right frequency in order to drive behavior change and, other desired outcomes. So basically, over the last 30 years in the video games business, we have distilled the neurochemical recipe for behavior change at scale. And we've done that by basically doing iterative testing on 3 billion unwitting test subjects. So we know how to hit the perfect balance of reward and frustration, challenge and skill to literally maximize the release of, say, dopamine in the brain at the optimal frequency to drive learning and drive behavior change. And we have many, many examples of this. One of them is, I always like to use, because people don't necessarily think about it this way, but the Obama administration spent 8 years and I think close to $2 to $3 billion to try to stem the obesity epidemic. I remember during their second term in the White House, Michelle Obama took it on as her personal mission to try to get overweight Americans just to get off the couch and go for a walk.
Mm-hmm.
And within 48 hours, all of these meritorious efforts were eclipsed by a single video game that got 40 million Americans up and walking for miles. And that's Pokemon Go.
Right.
I mean, I don't know what the situation was in downtown LA or Palo Alto. Downtown Chicago was a zombie apocalypse for 2 weeks.
Oh, LA was very similar to that as well.
Exactly. There are no kids in downtown Chicago. Like the average player of this game was in their late 20s.
Right.
And we think about this as some weird cultural phenomenon, but it's not. Every video game is doing this. It's changing your behavior. What was different about Pokemon Go is it was trying to get you to walk around strange neighborhoods and go for a walk and go places and explore. Most video games aren't getting you to do that, but they are getting you to come back every day, invite your friends, engage with sponsored content, learn how to play the game better.
Right.
There's a reason why tens of millions of Americans can name 50 Pokemon characters, but can't show you where Switzerland is on the map. You're welcome. It's because video games are exceedingly good at driving learning as an indirect consequence of play.
I think that's one thing that's actually really intriguing about virtual reality in medicine is that it's such an immersive technology that it engages patients almost, instantaneously when they put on the headset, and it brings them into a whole separate place to be able to, perform therapeutics, perform physical therapy, occupational therapy, anything like that, and really be able to get some substantive results from it.
Yes, virtual reality adds another layer and has additional benefit. So we see this, for example, when we're training medical professionals. Like I said, when we do on mobile, we're able to reach 2 orders of magnitude more people. So if we can do it on mobile, we do. There are certain scenarios, though, where VR provides benefit. Like if you're trying to train somebody really around, where things are placed in the operating room, or you're trying to train, let's say, CPR or intubation, where it's all about your position relative to the patient. Having that, VR experience is very helpful to help you develop that mental model. And the same thing goes for digital therapeutics. There are categories of digital therapeutics that are incredibly effective on a touchscreen. Put on a VR headset, it opens up new opportunities. You can do depth, stereoscopic visuals. There's more immersive audio. You can really remove the room, which provides you more control, especially with things like eye tracking is exceedingly helpful in creating that kind of closed loop iteration where you can detect how is the patient responding, and then make adjustments to the gameplay based on what they're observing and how well they're engaging with the content.
Yeah, that allows for better data collection too, as far as how the patient is responding.
Yes, exactly. We say there's a lot that healthcare can learn from the video games industry before you strap a brick to your head. But if you're going to strap a brick to your head, do it right.
Right.
So one of the things that comes to my mind as we talk about like the different features in video gaming and in virtual reality, as you said, like in terms of making sure that it's changing someone's behavior and that they're staying engaged and that they're learning the game, is how have you found your experience making video games for a commercial use and audience different from making video games for physician audience? So kind of focusing on who the audience is. I'm just curious to hear from you what that transition was like in terms of now knowing that with medical professionals, one of the key aspects is having that neuroscientific and clinical background. So I guess, can you maybe expand a little bit on what your experience was like in making video games for those two different audiences?
So first, I think the important thing to understand is the two are more similar than you would think. Doctors aren't some different species of human. They learn through play like the rest of us, and they want to be entertained like the rest of us, and they have a high bar for entertainment like the rest of us because they also play video games and watch Netflix. And so if you give them content that is mediocre, uninteresting, unengaging, not challenging, right, they will contrast that to their experience playing a video game either on their phone or, on their Xbox. So there's more similarity than you would think. We're utilizing some of the same game mechanics. When you think about, diagnosing a rare disease, for example, right? That's a reductive reasoning puzzle. That's a puzzle game. We're utilizing the same puzzle game mechanics that we use in consumer games, and we're, utilizing it to improve the performance of medical professionals. Because those puzzle game mechanics have been honed for decades over, again, hundreds of millions or billions of people. Now, the difference between Level X and other video game studios, you can tell pretty quickly. So we're structured pretty similarly. We have an engineering team and an art team and a QA team and a design team. We also have a dedicated medical team. And so on staff, we have MDs and biomedical engineers, and that gives us breadth. They're responsible for translating, so the artist understands what are the nuances of this movement disorder, or, when an artist is really making skin for a dermatology game, yep, this disease manifests this way above the pigment and below the pigment, which is why it's going to look different on skin of color. When it comes to depth in any medical specialty, that's where we have a cohort of literally hundreds of physician advisors and contributors across every major specialty in medicine who are peer reviewing every piece of content that we create. So all the content we create is peer reviewed by medical professionals, just like any article you read or other medical content you encounter. And if it's CME accredited, it goes through another level of peer review, which the first level of peer review is to make sure it's accurate medically. The second level of peer review is to validate that it's closing specific educational gaps.
Okay, so would it be correct to say that you do have physicians on your advisory board?
Oh, hundreds.
Okay.
And physicians on staff, like full-time employees. So we're the only video game studio with hundreds of physician advisors and contributors and physicians on staff.
Yeah, I think that's so important, being able to get their input, since they're the ones who are likely going to be using it, but also they have that clinical knowledge and background. And I guess to elaborate more on the game design process, when do you start that peer review process? Is it right from the beginning when you have an idea and you want to create a certain video game for medical purpose? Is it somewhere in between or just after you've done that? Can you give a timeline of what the game design process looks like?
So medical professionals are involved before anything. In fact, really, the way we determine what game we're going to build next is based on demand from physicians. So literally, like, the reason we built a cardiology game was because we discovered we had 4,000 cardiologists playing our gastroenterology and pulmonology games. And so based on demand from their specialty, that's what motivated us to make sure our next game was in cardiology. The decision about what we build next is driven by our physician audience. Then the next step is, okay, what do we build? Peer review comes much later, right? What we're in the business of doing is capturing the challenges of the practice of medicine. We don't know what that is. So we rely on medical professionals to tell us that, and we drill into it with them in detail to figure out what game mechanics we should employ, right? Just thinking about like, all right, what is challenging about, diagnosing this disease, down to very, very subtle nuances. Like if you ask a doctor what is difficult for you to do, they'll often default, their cognitive bias is to answer it by describing what's difficult for a resident to learn, which is very different than when you're trying to make a game for a practicing physician to become more expert, right? So for example, we were making a gastroenterology game. We always learn these things the hard way. So early on, we were making a gastroenterology game. And we were asking, like, how do you differentiate an expert and a novice? They go, well, what's really hard for residents is the colon is basically like a deflated balloon. So the way you can tell an expert from a novice is the colonoscope, you can inflate it. You can apply air pressure and it'll inflate the balloon. It'll help you navigate, but it causes discomfort to the patient. So the way you tell the difference between an expert and a novice is how much length of scope they need to use, how much they're inflating because they don't know their way around. And so great. So we built this whole game mechanic where you inflate the colon and we score you based on that, and you navigate your way through. And we put that to practicing gastroenterologists. And they were like, well, this isn't fun. We said, oh, but you said this was hard. They go, well, this is hard for residents to learn. Once you're good at it, it's easy. I don't want to be navigating through the colon. Take me right to the action. Where's that tumor? Where's that bleeding polyp? I want to get over it. That's hard for me. And so we really have to reorient our questions. It's interesting from a psychiatry perspective and a neuroscience perspective to really make sure we're drilling in with them, not what's hard for trainees to learn, what's challenging for you, what gives you an adrenaline rush in the operating room, what's the thing that you see in the clinic that gives you an aha moment. What is it? Is it something you see? Is it something you hear? What is their emotional response? What triggers that? Because those are the elements that we're going to want to capture to put into the video game.
Yeah, that is so fascinating. Thank you.
So virtual reality is still in its very early stages regarding graphics, right? So how do you see VR becoming even more immersive as technology progresses? And what do companies need to do to ensure that that happens? In other words, what steps should companies take to continuously improve their experiences, in addition to ensuring that your audience is getting what they need to get out of your platform?
So I will give the same answer that I often give, which is look at what the games industry is doing because they are very far ahead. So the games industry, I just had a conversation with somebody about this a couple of days ago, one of the major VR companies, like they're already doing things like they're tracking your eye movement and they're using that to make sure that these VR headsets, for example, have crazy high resolution. They're getting into 4K, they're getting into 8K if you look at some of the newer devices. And, you don't actually have that many neurons in your eye, right?
Right.
I'm going to use the wrong terms, but like the density of neurons in your eye is basically the equivalent to, holding your thumb out at arm's length. That area of your visual field is where you can actually see detail, like reading text. So they detect where your eyes are looking, and that's where they throw all the graphical compute power to generate the maximum amount of realism at the specific point you're looking at. This is the level of sophistication that we're using in video games in VR to make them even more realistic. So we can maximize how realistic characters and environments look. On the healthcare side, nobody's doing this.
Right.
Yeah.
Mm-hmm.
So if you want to see what's 5-10 years ahead, look at what the entertainment industry is doing and just borrow that.
Right.
And they'll tell you, they're not secretive about it. The games industry is very open about the innovation that they do and the new techniques that they come up with. As is Level X. That's why we're constantly, getting up on stage at Game Developer Conference and sharing, how we do computational fluid dynamics to simulate blood on an iPhone.
Right. You have a research project being sent to the International Space Station on SpaceX's Polaris Dawn mission launching this summer. Can you tell us about that project?
We've actually been working with NASA for several years through the Translational Research Institute for Space Health to adapt this technology to help train astronauts for medical emergencies in space. The original NASA project was actually funded through the Mars mission. I'll give you that scenario because the SpaceX mission is actually a step along that path.
Okay.
So imagine you're 9 months into the Mars mission. It's going to take 9 months. They've already picked the propulsion system.
Mm-hmm.
And one of the astronauts grabs his chest and rolls over in microgravity, unconscious. What do? It's going to be the flight surgeon. It's always the flight surgeon. You've seen movies. So, okay, what do? So first off, you're in a resource limited environment, resource constraint. There's no MRI, there's no CT scanner on the spacecraft, not because they can't afford it financially, but because you can't afford the mass.
Right.
So the only imaging modality you have is ultrasound. That's the only way to visualize what's going on, which, as you know, leaves much to be desired.
Mm-hmm.
A whole other slew of other problems. Your heart physically changes shape in microgravity. Your blood flow direction can change. How do I know that what I'm looking at under the ultrasound is normal for an astronaut who's been in space for 9 months or abnormal? And then the experts aren't there. Today on the ISS, they have an ultrasound rig, and there's a radiologist on the ground in Houston who we work with who does real-time analysis. So he'll tell them like, all right, push in, give me 10 degrees to the left, and they will adjust it. And in real time, he'll read the result. If you're 9 months into the Mars mission, it's 40 minutes for the speed of light to make the round trip. So you can't, doing an ultrasound exam would take 9 hours.
Right.
So we need to be able to provide just-in-time training. So what we're testing on the SpaceX mission and on Polaris Dawn, we're actually launching some game content we've built for NASA. So on the Polaris Dawn mission, on these private spaceflight missions, they do medical experiments. And one of those experiments is using ultrasound to measure the change in blood flow in the jugular vein. But what we're doing is we're not training them how to use the ultrasound device on Earth. We're actually testing the effectiveness of just-in-time training in microgravity, training them how to do it in space. So we're sending up on the spacecraft a game for them to learn how to do the experiment, and then they do the experiment. So we're able to do a study.
That's going to be so valuable as there's more commercial space exploration. Just having that tool to be able to say, okay, how is your body reacting to this environment is going to be so valuable.
Exactly. And what's cool about it is we retain the terrestrial rights to this technology we're creating. So we've actually been working with NASA to create the most realistic real-time ultrasound simulator in the world to train all this stuff. And now we're using it here on Earth to train doctors and a broad swath of clinicians how to use ultrasound from everything from, point of care, neurosurgery, intravascular ultrasound, all sorts of stuff.
Right. Absolutely. So do you see VR being used to explore space health in the future?
I think there are already applications of using VR for that. And a lot of that is because you're actually in a pretty interesting, constrained environment. So teaching somebody how to, just thinking about the logistics of intubating a patient in microgravity, right? Here on Earth, the patient's on the ground, they're already laying on their back.
Right.
There's no laying on your back in space. So if you want to intubate a patient, you've got to brace them against the wall somehow while you're holding the scope in your other hand, but then you can't manipulate their jaw. So these are scenarios where virtual reality allows you to create that. You can turn off gravity. You can put on a VR headset where it's literally, all right, you're operating in a tiny space. Person's here. Your tool is there. How are you going to get a visual on the vocal cords? How are you going to position yourself to be able to do that procedure? And so VR opens up a bunch of interesting scenarios that you can't necessarily recreate without being in a zero gravity environment.
So one thing that comes to mind is, many people report that VR leads to cyber sickness or motion sickness. Do you see that being a challenge in space for astronauts, like space motion sickness or disorientation?
The two are related in that they're tied to your vestibular system. I think there are some projects underway to try to simulate some of that. I think what we should do is just, even before we get there, the whole topic of nausea and dizziness caused by VR experiences. This is, again, an area where I think healthcare can learn a lot from the entertainment and video games industry, because usually what causes disorientation in VR experiences is not the hardware. It's badly designed VR experiences. If you've ever been, probably they do this at psychiatry conferences, but pretty much in every medical specialty, they have these, what they call mechanism of action videos or animations where they show you how the drug works at the molecular or cellular level. And they're gorgeous, like they're getting to Pixar quality. But there's so many of them, like people don't really watch them for very long. And so the tact a couple of years ago was, well, what we'll do is we'll take that video where we're flying around the molecule, and instead of putting it on a big screen, we're going to sit you down in an egg chair, shove a VR headset on your head, and make you watch it. And what causes seasickness is you're on a boat, you're inside the boat, you feel the boat moving, but you look around and you're in a room that isn't moving, and your visual system goes out of sync with your vestibular system, and that triggers nausea. You trigger the exact same effect when you create a VR experience where you're flying around a molecule, but you yourself are sitting in an egg chair not moving. And so from a marketing perspective, nausea is the last thing that you want associated with your brand, unless, of course, your brand is indicated for nausea. But we've seen just endless, really, really bad VR implementations in healthcare. And if you look at video games, they don't do that. Like if they're going to move you around, they're going to be very deliberate about how they do it. They're either going to have you walk around a physical space, so you're physically moving, or there are very controlled ways of putting you in a large platform or something that's moving with you, so the perception of movement is limited. There are all sorts of techniques that we use in games to deliver the high quality experience without triggering the nausea. But you have to know the neuroscience and you have to know the best practices in order to do it right.
Got it.
Sam, thank you so much for joining us today. Is there anything else that you would like to add?
I mean, the only thing I'd like to add is we've been talking a lot about all these experiences where you're doing virtual colonoscopies and having conversations with virtual patients and diagnosing rare disease. And I've been waving my hands, but nobody can see them. So if anyone wants to actually check any of this out, just go to levelx.com, levelex.com, and you'll be able to see there are examples you can literally play in your web browser from your PC or your phone, or it'll hop you over to the App Store where you can download any of our games and just try them out for yourself.
And we'll include a link for our listeners on our website as well to levelex.com. So easy access there.
Fantastic.
Yeah, absolutely. Sam, thank you so much for joining us.
Thank you for having me. This was a lot of fun.
Thank you so much, Sam.
That's it for this episode of Psychiatry XR. We hope you gained a new perspective on using extended reality in healthcare, and thanks for listening. This episode was brought to you by Psychiatry XR, the psychiatry podcast about immersive technology and mental health. For more information about Psychiatry XR, visit our website at psychiatryxr.com. Be sure to subscribe to the podcast and tune in again next month to hear from another guest about XR use in psychiatric care. You can join us monthly on Apple Podcasts, Twitter, Spotify, or wherever you get your podcast. Psychiatry XR was produced by Dr. Kim Bullock, Faaizah Arshad, and myself, Jessica Hagen. Please note this podcast is distinct from Dr. Bullock's clinical, teaching, and research roles at Stanford University. The information provided is not medical advice and should not be considered or taken as a replacement for medical advice. This episode was edited by David Bell, and music and audio was produced by Austin Hagen. See you next time.